Okay, starting off with target 3, remember rate of change is just asking for the slope. So our goal in all of these cases is to find the slope, which is the variable m. So anytime you're given 2 points like you are on number 1, so the first thing you could technically do is get some graph paper, graph these 2 points, and do rise over run. What I'm going to choose to do instead is to use the slope formula, because I don't want to get graph paper out and do all that. And then remember, we have to label our points. So I'm going to say this is x1, y1, x2, y2, and then just fill in what you got. So y2 is negative 11, y1 is 7, x2 is 18, minus x1, which is 11. So simplifying that, so negative 11 minus 7 is negative 18. Negative 18 minus 11 would be 7. And we can't simplify that any further, so that would be our final answer. If you're finding the rate of change given an equation, the first thing you want to do is ask yourself if it's in slope-intercept form. In this case, it's not, and I know that because it does not read as y equals. So my goal is to get this into y equals form. So I'm going to subtract 2x. So don't lose that negative in front of the y, that'll be important. So notice I didn't combine the negative 2x plus 2 since those are not like terms. And remember, you do have to divide by a negative 1 to get rid of that negative out in front. So our slope-intercept form is y equals 2x minus 2. So figure out where your slope is sitting in front of your x. So the slope is 2. Now we're going to find the rate of change given some graphs. So on number 3, this is a vertical line. And so anytime you have a vertical line, you don't even have to do a lot of work. The slope is undefined. And then on number 4, to find the slope, think about this as rise over run. So we actually went down, we didn't rise. 1, 2, 3, 4, 5, 6. So down 6, and we ran 2. We went to the right 2. So our slope would be negative 6 over 2, which does simplify to negative 3. And you could leave that as negative 3 over 1 if you wanted to, but you do need to simplify it. And now we're going to find the rate of change from tables. So remember in your notes we talked about you want to make sure your x values are in increasing order and you don't skip any x values, which is true in both of these cases. So then we want to think about the rate of change. So to go from 1/4 to 3/4, how much are we adding? Well, we're adding a half. And then you want to make sure that that's true all the way down your table. And it is in this case. And if it is true all the way down, that's your slope. If it's not true, that means it's not a linear function. We're trying to trick you on something. So then on this next one, this one's kind of harder to figure out. Maybe you were kind of having a hard time figuring out what the rate of change was on 5. So what I like to do in order to figure out the rate of change is if I'm finding the rate of change between those 2 points, I actually take the second one, which is 13.2, and I subtract the first one, and it's negative 3.8. And then you can do that again. So here, let's do 9.4 minus 13.2, and it's negative 3.8 again, and you can verify that this last one is also negative 3.8. So your slope is negative 3.8. Now, number 7, we didn't really talk about on your notes, but this is actually a really important topic when it comes to the ACT, which you may or may not be thinking about yet. But the ACT always asks about the slopes of parallel and perpendicular lines. So just kind of as a side note, if you have parallel lines, that means the slopes are the same. Now that's not the case here, because if you read the problem, we're looking for the slope of the line perpendicular. So perpendicular lines, they have what we call opposite reciprocal slopes. Reciprocal. So opposite just means you change the sign. If it was positive, you make it negative. If it was negative, you make it positive. Reciprocal means that you flip the fraction. So the very first thing we have to do to answer this question is we've got to know what the slope is. So that actually goes up, and this problem is very similar to what we did on number 2. We're going to put this equation in slope-intercept form to figure out what's the slope of this line. So slope-intercept form means it's y equals. Okay, so I have it in slope-intercept form. So if I asked you what's the slope of this line, hopefully you would tell me it's -4. But remember, we're looking for the slope of the perpendicular line. So we're going to have to make this the opposite sign. So since -4 is negative, our answer is going to be positive, and we're going to flip the fraction. So if you think about that as -4/1, the perpendicular slope would be a positive 1/4, just flipping the numerator and denominator. So the correct answer would be D. Moving on to the back of your homework, this is where we're going to be doing some graphing. So starting off on number 8, lots of ways to do number 8. You could just put it in slope-intercept form like we talked about on the front of your homework, we talked about on your notes. But remember, since you have to find the x and y intercept eventually, you could also just find the x and y intercept and use those to graph. So I'm going to start with that. So to find the x-intercept, we make y equal to 0. So we have 7x minus 3 times 0 equals 6. 3 times 0 is just 0. So this is really 7x equals 6. Divide by 7. Now this doesn't come out nicely, but I am going to actually put this as a decimal, which I don't do a lot of. I try to keep things as fractions, but the reason I want to keep it as I want to write it as a decimal is I'm graphing it. So I got to know where to plot that point, and it comes out to be 0.86. So again, we just found the x-intercept, so 0.860. So I'm going to plot that, and it's going to be, I mean, it looks like it's at 1, but we know that it's just a little bit before 1. And now I'm going to find the y-intercept. So to find the y-intercept, I'm going to make x equal to 0. So I'm going to do 7 times 0, making x equal to 0, minus 3y equals 6. That's just 0. So I have negative 3y equals 6. If I divide by negative 3, I get y equals negative 2. So the y-intercept is 0, -2, which is right here. And then we can graph that line. Again, you could have found this, put this in slope-intercept form and absolutely graphed it that way, no problem. Domain and range. Domain, how far to the left and right does this graph go? It's going to go forever to the left and right. So we use all real numbers. And you can write that out if you want to, if you don't like that symbol. I'm lazy, so I'm going to use the symbol. And then the range, how far up and down. This graph is going to go forever up, forever down, all real numbers. And there we have our graph of number 8. Number 9, don't let this trick you. Y equals 2. If it's y equals a number, that's just a horizontal line. So let's make a horizontal line at 2. Graphing is super easy there as long as it doesn't trip you up. All right, let's go down our list of information we have to find. Domain, how far to the left and right? A horizontal line goes forever to the left and right. Range, how far up and down? Well, it doesn't go up and down at all. It just stays at that y value of 2. So we just write y equals 2. X-intercept, none. Doesn't cross the x-axis. Won't cross the x-axis. And the y-intercept would be at 0, 2. We can see that from the graph. And then our last problem here at the bottom, number 10, is in slope-intercept form. So I know this looks kind of strange, but just think of this. I'm going to write it slightly differently. Y equals -3/5 x minus 5. So the slope is -3/5. The y-intercept is -5. So if we have slope-intercept form, we're going to make our y-intercept at -5. I'm going to start there. and then use our slope. So go down 3, 1, 2, 3 over 5, 1, 2, 3, 4, 5. Now, when you went down and over, make sure that your graph is going downhill because that is a negative slope. And I'm actually going to go in the opposite direction as well and make another point just because otherwise my graph isn't very accurate. Not a very good artist here. All right, so we have our graph, so now we can find our information. Domain, how far to the left and right, forever. Range, how far up and down, forever. Remember, the only time you're going to have a case where your domain or your range is not all real numbers is if it's a horizontal or a vertical line. So anytime your graph has any sort of a slant like this one, your domain and range is going to be all real numbers. Now your x-intercept, we can't see where your x-intercept is, and even if we continued our line and we went up 3, back 5, it would be at some sort of a decimal. So in this case, to find your x-intercept, we are going to have to solve for it just like we did on number 9. I'm sorry, on number 8. So your x-intercept, we make y equal to 0. So let's go back to that original equation, and we're making y equal to 0. And now we're going to solve for x. So I'm going to add 5. 5 equals negative 3/5 x. Divide by negative 3/5, and you want to be careful when you put this into your calculator. I'm going to actually put this into my calculator as well. And we're just going to do decimals because anytime we're graphing, it's just going to be easier that way. So 5 divided by negative 3/5 is negative 8.3. Now let's make sure that that makes sense in terms of our graph. So negative 8.3 would be like right there, which does make sense. But now we have the exact value. And then the y-intercept we don't need to solve for. We can just see where the y-intercept was on this problem, which was at 0, negative 5. And that's your homework for targets 3 through 5.